Okay, question 12, we have some SUVAT. So, a particle moves on a straight line with a constant acceleration of a meters per second squared. The initial velocity of the particle is u meters per second squared. After t seconds, the velocity of the particle is v meters per second. This information is shown on the velocity time graph here. Okay, then we're told the displacement s meters of the particle from its initial position at time t seconds is given by s equals 1/2 u and v times t. So these are all things that we already know. Part A says by considering the gradient of the graph or otherwise, find an expression for A in terms of u, v and t. So acceleration is the rate of change of velocity over time. So on a velocity time graph, it's the gradient of the line. So we have two coordinates. We've got 0, u, and then this guy up here is t, v. So gradient is difference in y over difference in x. So A is v minus u over t minus 0. So it's just v minus u over t. Okay, then for part B, hence show that v squared is equal to u squared add 2as. So we know s is 1/2 u add v times t. So the formula up above does not have a t involved. Now we also just worked out that A is v minus u over t. So what we can do from that is get a formula for t in terms of v, u and a. So if we multiply through by t, at is v minus u, and then divide by a, we get t is v minus u all over a. Now we can substitute that into our formula for s. So now we can say s is 1/2 times u plus v times v minus u all over a. So this on the right is now s equals, I'm going to write the first bracket as v plus u, we got that times v minus u all over 2a. Now if we multiply through by 2a, we get 2as, and if we expand the brackets, it's a difference of two squares. We get v squared minus u squared. Add the u squared, and we finally get v squared is u squared add 2 A S. Job done.